डिस्कस करेंगे इलेक्ट्रिक फील्ड। In the simplest words, electric field at any point in space is equal to electric, I should say, net electric force acting at that point, acting at a unit charge, unit positive charge. At a unit positive charge placed at that point. Electric field at any point in space is equal to net electric force acting at a unit positive charge placed at that point. इसका मतलब ये है कि अगर suppose I want electric field at this point, so what you do, if I want electric field at point P, you put a unit positive charge, correct? How much charge you put? Unit positive charge. That means plus 1 coulomb of charge you put here, and see how much force is acting on it in which direction, correct? Let us say 2 Newton force is acting. So the electric field, 2 Newton force is acting on 1 coulomb charge placed at this point. So the electric field at this point will be called as 2 Newton per coulomb. So electric field is a vector quantity, is defined by electric force per unit charge. The unit of force is Newton, the unit of charge is coulomb, that's why Newton per coulomb, right? Now what was the need to define a quantity called electric field, right? You need to remember that electric field is a vector quantity. That means it has magnitude as well as direction. Okay. Now let's see what was the need to define electric field. Okay. So suppose you have a Q1 charge placed here, and you want to calculate the value of electric field at r distance from this charge. There's a point P, you want to calculate the value of electric field at point P. Okay. So value of electric field at point P is that if you put a unit positive charge at point P, how much force is acting on that, that is the value of electric field at point P. Okay, suppose you are interested in what is the electric force acting at point P. So suppose if I put a plus 2 coulomb charge at point P, how much electric force is acting? Suppose if I put plus 5 coulomb charge at point P, how much force is acting? Plus 8 coulomb charge at point P, how much force is acting? So this calculation of how much force is acting on a given charge can be done by, since the definition is electric field is electric force by Q, so electric force is equal to Q times E. Correct? So that means if you want to calculate the force on 2 coulomb charge, simply multiplied by the magnitude of the force is simply the charge multiplied by the value of electric field, right? So if I calculate the electric field at this point, then if I want to find the force acting on a 2 coulomb charge put at this point, simply multiply charge by the electric field. Similarly for 5 coulomb, similarly for 8 coulomb. Every time I will not have to use the Coulomb's law, 1 by 4 pi epsilon naught q1 q2 by r square, like that, because this charge is common in all of them. Okay, so now let us calculate what is the electric field at point P. So let's say if you put a q2 charge at point P, that q2 can represent any of these values, then how much force q1 is applying? So force acting on charge q2 due to q1, this is 1 by 4 pi epsilon naught q1 q2 by r square, that is the force. So, and the direction is you can say towards right, that is the direction. Okay, so the value of electric field will be this force by charge, now divided by which charge? q2, because this much force is acting on q2 charge, so how much force is acting on unit charge divided by q2. So if you divide this thing by q2, you get 1 by 4 pi epsilon naught q1 by r square. This is the value of electric field towards right. Correct? So the value of electric field due to a charge at a distance r from it depends on the value of the charge and the distance of the point from that charge. So we say this value of electric field, this 1 by 4 pi epsilon naught is constant, it depends on q1, it depends upon r square. So value of electric field due to charge q1 at a distance r from it will be 1 by 4 pi epsilon naught q by r square. So if I double this charge, the value of electric field will double, because electric field is directly proportional to the charge value. And if I double the distance, since it is inversely proportional to r square, electric field is inversely proportional to r square. So if I double the distance, the electric field will become 1/4. Correct? The electric field value at point P due to q1 does not depend on the charges. Correct? So if I bring this charge here, the value of electric field will remain the same. Correct? Let us say the force which is acting on 2 coulomb is 20 Newton. So the force which is acting on, I am taking a assumed value. The force at 2 coulomb, if we put a 2 coulomb charge here, a 20 Newton force acts, that means force acting per unit charge here will be 20 by 2, which is 10. Similarly, for 2 coulomb, 20 Newton will act, and 5 coulomb, 50 Newton will act, force per unit charge will remain the same. That means electric field will remain the same. So the electric force that is acting on each of the charges will depend on the value of this charge also, as well as this charge and the distance. But the electric field at this point will not depend on the values of this charge, these charges. Correct? So because that electric field is due to this. Now the other question that comes to mind, जो चीज़ आती है दिमाग में, वो ये है कि अगर यहाँ पर कोई चार्ज पुट किया तो क्या इस पर भी फोर्स नहीं लग रहा है? There is a, this is also acted upon by force from this. Correct? This is applying force on this, but this is also applying force on this. But then this is not the point which is in question. The point is P. The question is, what is the force acting on unit positive charge placed at point P? That is the value of electric field. Okay. So that is this value. So once you got this electric field, if you multiply it into Q2, correct? So F is equal to QE. If you want to know how much force acting on charge Q2, that force will be simply use this formula and you say Q2 times E, which is this, how much, 1 by 4 pi epsilon naught Q1 by R square. So ultimately this is the same expression that you get from Coulomb's law. So there are two ways to calculate the force acting on a charge which is placed in the vicinity of other charge. How much force is acting on this due to this? There are two ways. One way is directly you use Coulomb's law, 1 by 4 pi epsilon naught Q1 Q2 by R square. The other way is calculate the value of electric field due to this charge at this point and multiply this charge by that value of electric field, you will get the force acting on this charge. Right? So this is the basic of electric field. Now we'll see the direction aspect of electric field. Okay, some very common electric fields. So let us take example. So we take an isolated positive charge, isolated negative charge, and a combination of positive and negative charge. For example, so electric field, what you have to remember is, since the electric field, whenever direction you have want the direction of electric field, what you have to keep in mind is that electric field is nothing but electric force on unit positive charge. So the direction of electric field will be the direction of electric force only. Correct? So whenever you are doubtful about the direction of electric field, just find out the direction of net electric force at that point. That should be the direction of electric field. Okay. So if you take positive charge, now if I put a positive charge near it, now right now we are taking only direction. If you take a positive charge here, the force that this will apply on this, correct, will be along this. The force that this will apply on will be this. So at this point the force will be like this, at this point like this. So if you join all the lines, we say this is the electric field line. So electric field line at any point shows you the direction of electric field. This is how we show electric field. We call it this the force field, this is an electric field. Okay. So you put a unit positive charge radially upward, it will push. Similarly, if you have a negative charge and near to it if you put a positive charge, it will attract. So these will be the electric field lines. Similar to this, there's no doubt about it. Okay. And these are very simple cases. Now let us see. So they are not placed side by side. These two examples are separate. When this is there, this is not there. When this is there, this is not there. Now let us say if you put two, when you have more than one charge. What if there is a positive charge and next to it there is a negative charge? Now how will you know the direction of electric field? Very simple, choose any point you want. Let us say you choose this point. Okay. If you put a positive charge here, this will repel it, this will attract it. The resultant of these two, if you take these two vectors, so this one will be resolved like this and this will be resolved like this and this. So if you see this and this will add up, this will cancel. So the resultant of these two will be in this direction. Similarly, you can see the value of electric field at any point. So suppose you want here the electric field. If this is not there, the electric field will be like this. But since this is there, so it puts, since distance is more, so it puts a strong force like this. So the resultant is not exactly like this, but a little bit this way. correct? So what we see is the electric field direction comes out to be like this. It's like this and this, correct? And okay, so this diagram is there in the NCERT. You can see the diagram, but this is roughly the idea. At any point you want to get the value of electric field. Of course, on this side you can simply draw like this, right? So at this point, if you see, there will be a force due to this, and there will be a light force due to this, so it will bend. So correct na? Force due to this will be like this. Force due to this will be at this point. This will be repulsive force due to this line joining this and this, attractive force. So the resultant of these two will come slightly along this. So these lines will go something like this. That decides the direction of the curve. It is concave upward, concave downward. Similarly, if you take this point, let us say, now this will attract it like this, and this will repel it slightly like this, correct? So the direction here will become somewhat like this, resultant of these two. So it will be somewhat like this. Okay, fine. So this is the direction of electric field when two charges are present. Okay. Now, ठीक है, तो हर चीज़ को conceptually समझना है, क्योंकि इलेक्ट्रिक फील्ड हमेशा डिफाइन होती है इलेक्ट्रिक फोर्स के थ्रू. तो जब ऐसा नहीं है कि इलेक्ट्रिक फील्ड का क्वेश्चन, इट इज़ सच अ बेसिक कंसेप्ट कि इसका क्वेश्चन कॉम्पिटिटिव एग्जामिनेशन में नहीं पूछा जा सकता है. पूछा जाएगा, और जब भी पूछा जाएगा तो कंसेप्ट को थॉरली टेस्ट किया जाएगा, वेदर यू अंडरस्टैंड वेयर इट कम्स फ्रॉम. ठीक है, तो एंड इट विल बी एन एंटायरली न्यू सिचुएशन. सेम एग्जांपल्स जो बुक में दिए वो नहीं पूछा जाएगा. ओके ओके, सो दिस इज द इलेक्ट्रिक फील्ड इन दिस सिचुएशन. ओके, नाउ सपोज करो हमारे पास एक पॉजिटिवली चार्ज प्लेट है और एक नेगेटिवली चार्ज प्लेट है. इनके बीच में इलेक्ट्रिक फील्ड की डायरेक्शन पता करनी है. कोई बात नहीं, पॉजिटिव चार्ज पुट कर दो, स्मॉल पॉजिटिव चार्ज. ये रिपेल करेगा, ये अट्रैक्ट करेगा, तो इलेक्ट्रिक फील्ड की डायरेक्शन ऐसे होगी. क्या प्रॉब्लम है? नो इशू. यहाँ पर इलेक्ट्रिक फील्ड की डायरेक्शन, ये रिपेल करेगा वीकली, सॉरी ये रिपेल करेगा स्ट्रांगली क्योंकि इसकी डिस्टेंस कम है. ये अट्रैक्ट करेगा वीकली, ये वाली प्लेट इस पॉजिटिव चार्ज को वीकली अट्रैक्ट करेगी क्योंकि इस वाली प्लेट की इस पॉजिटिव चार्ज से डिस्टेंस ज़्यादा है कंपेयर टू दिस, कंपेयर टू इस प्लेट से डिस्टेंस जो है. तो नेट रिजल्टेंट इसका इस डायरेक्शन में आएगा. एंड सिमिलरली अगर हमने यहाँ पे रखा तो दिस विल अट्रैक्ट, दिस विल स्ट्रांगली अट्रैक्ट एंड दिस विल वीकली रिपेल. सो यहाँ नेट इलेक्ट्रिक फील्ड की डायरेक्शन ऐसे होगी. ठीक, सो दैट इज द, और यहाँ पर जो इलेक्ट्रिक फील्ड होगी सब जगह पर इक्वल होगी. अब हम आते हैं इलेक्ट्रिक फील्ड लाइंस क्या रिप्रेजेंट करते हैं. तो जैसा कि हमने देखा था, अगर एक पॉजिटिव चार्ज है इसके पास इलेक्ट्रिक फील्ड लाइंस हम ऐसे बनाते हैं. ठीक है, और पॉजिटिव चार्ज से कुछ डिस्टेंस पर इलेक्ट्रिक फील्ड की वैल्यू कितनी होती है? 1/4πε0 Q/r², अगर ये Q चार्ज है तो. ठीक है, तो ओके, तो ये कांस्टेंट है. तो बेसिकली ये है कि इलेक्ट्रिक फील्ड इज इनवर्सली प्रोपोर्शनल टू r². तो जैसे जैसे हम दूर जाएंगे इलेक्ट्रिक फील्ड की इंटेंसिटी कम होती जाएगी. एंड दैट वी कैन ऑब्जर्व इन दैट द फैक्ट दैट लाइन आर बिकम, लाइंस के बीच का जो डिस्टेंस है वो बढ़ता जा रहा है ना. सो इन रियलिटी ऐसा नहीं है कि हर एक चार्ज के चारों तरफ सिर्फ 6 लाइंस होती हैं, इन्फिनिट नंबर ऑफ लाइंस है. बट एट एनी पॉइंट देयर आर इन्फिनिट नंबर ऑफ लाइंस, बिकॉज किसी भी पॉइंट पर तुम रख दो यहाँ पर पॉजिटिव चार्ज को, वो फोर्स एक्सपीरियंस करेगा. ठीक है, ठीक है, तो दे आर इन्फिनिट नंबर ऑफ लाइन्स, बट दिस इज representative of how the electric field will be like. So electric field is representative of किस डायरेक्शन में इलेक्ट्रिक फोर्स एक्ट करेगा. ओके, एज फार एज डायरेक्शन ऑफ इलेक्ट्रिक फील्ड इज कंसर्न. नाउ ऑल्सो सपोज बहुत सारा इलेक्ट्रिक फील्ड लाइन्स है, तो जैसे जैसे दूर जा रहा है तो लाइन्स के बीच का डिस्टेंस बढ़ता जा रहा है. दैट मीन्स अगर यूनिट एरिया हमने यहाँ पर लिया, पास लिया यूनिट एरिया, तो उसमें से जितनी लाइन्स पास करेंगी कंपेयर टू दैट सेम यूनिट एरिया अगर थोड़ा डिस्टेंस पे लिया, तो नाउ लेस नंबर ऑफ इलेक्ट्रिक फील्ड लाइन्स विल पास थ्रू दिस, बिकॉज लाइन्स के बीच का सेपरेशन बढ़ रहा है. तो फॉर एग्जांपल अगर मैं यहाँ पर काफ़ी डेंस इलेक्ट्रिक फील्ड लाइन्स बना दूँ रेडियली, ठीक है, तो तुम देखो यहाँ पर कितनी है 1 2 3 4 5 6, और यहाँ पर मैक्सिमम 3 4. So you can see that electric field intensity here is less compared to what it is here. है ना? So this is about electric field intensity. I think that electric field के discussion में अभी इतना ही काफ़ी है. नेक्स्ट कंसेप्ट जो हम डिस्कस करेंगे वो होगा इलेक्ट्रिक पोटेंशियल एनर्जी और इलेक्ट्रिक पोटेंशियल. इलेक्ट्रिक पोटेंशियल एनर्जी और इलेक्ट्रिक पोटेंशियल इज नथिंग बट इलेक्ट्रिक पोटेंशियल एनर्जी पर यूनिट चार्ज. तो ये दोनों रिलेटेड क्वांटिटीज़ हैं.